All right, this is 6-5. We are getting towards the end, and we are finally to right triangle trig, which I know for a fact we did freshman year, and I think you probably did it in Algebra 2 as well. So hopefully this isn't too difficult or it's anything too new. So if we're talking about right triangles, okay, so you know what a right triangle looks like. There are two legs, okay, leg, and the hypotenuse. And if you have an angle swooped, you have an opposite, you have an adjacent, and you have a hypotenuse. Okay, so right triangle trig is all about the relationships between those legs and whatever angle you're talking about. So if we're talking about the sine of the angle, that's opposite over hypotenuse. Okay, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, also known as SOHCAHTOA. SOHCAHTOA. Okay, SOHCAHTOA. That's what we're doing for the next two sections, and then we're done with notes. So right triangle trig, SOHCAHTOA. This is everything you need to know. Sine's opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent's opposite over adjacent. So when you have a triangle, you need to have an angle of focus. That's the biggest thing. Once you know what angle you're focusing on, you swoop it and label your sides and then decide which function you need to be using. Okay? So when you give an angle, decide what relationship you can use with the sides and the angles. So you got to swoop the angle, label your sides, and decide sine, cosine, or tangent. Set up your proportions, and then solve for the missing side length or the missing angle, depending. Okay? If you're finding the angle, make sure you second sine, second cosine, second tangent, whatever you have, because you're looking for an angle and you will only know the sine, the cosine, or the tangent. That's no different than it was before. Okay? Then, so we're going to look at this. In right triangle ABC, the measure of side A is 12 and angle B is 62. We're asked to find side B. So I gave you a picture already. You need to have an angle of focus. So our angle is the angle they gave us, which is B. So in relationship to angle B, this is the opposite, this is the adjacent, and this is your hypotenuse. Okay, your hypotenuse is always across from your right angle. Opposite's across from the angle you're talking about, and then the adjacent is the other one, or the one next to the angle that you're talking about. Okay? So then you highlight the sides you know and what you are trying to find. Okay? This is what we know, and this is what we're trying to find. So we know the angle, and we are using opposite and adjacent. So opposite and adjacent is tangent. Okay? So you label the sides and highlight what you know or what you're looking for. So two sides should be highlighted. Then you are going to set up your proportions based on what you know. So the tangent of your angle. So we know the angle. So the tangent of 62 equals. And then you set up opposite over adjacent. So opposite is B, we don't know B, over adjacent, which is 12. Okay? And then we need to solve for whatever we don't know, which is side B. So B is being divided by 12, so I'm going to multiply both sides by 12. So we just do 12 tangent 62. And since it's a side length, we're going to go nearest tenth, which is 22.6. And then that's it. Because that was the side length, we didn't need a second sign or do anything else to it. So that's it. Figured out which function we needed to use, set up the proportions, and solved for what we didn't know. So this one has a triangle, but I didn't really give you any other information, so we got to fill it in first. So side A is 8. So side A across from angle A is 8. Side B across from angle B is 5. and we are being asked to find the measure of angle B. So B is my angle of focus, so I'm swooping. So in relationship to B, this is my opposite. Hypotenuse is always across, excuse me, from C, and then the adjacent is the one left over. So this time we know two sides, so those are the two we highlight. We highlighted the opposite and the adjacent, which again is tangent, okay? So we're going to be using tangent, but this time when I set it up, so tangent theta, I do not know angle B, okay? So I'm going to say tangent B equals. Opposite is 5 and adjacent is 8, so I just set up the proportion. So 5 divided by 8, if I divide it out, that's fine. So that's 0.625. So the tangent of B is 0.625. So I need to know angle B, so I second tangent it. So second tangent, second answer, and we're doing nearest, so whole number for angles, which is 32 degrees. And that's it. All right, this one says a ladder is placed against the wall at a 75-degree angle. How far is the 14-foot ladder away from the wall? So I drew this for you already, but this is the wall. Here's the ladder. The angle is the base angle, and the ladder is 14 feet long. And we want to know how far away the ladder is from the wall, which is down here. The wall to the ladder, how far away is that? That's what we're trying to find. Okay? So we swoop and label. So we swoop the angle we know. This is my opposite. This is my hypotenuse. This is my adjacent. Highlight the things you know or the things you are trying to find. So we know the hypotenuse and we are trying to find the adjacent. So those are the two things I need to use. So I am doing adjacent over hypotenuse, which is cosine. Okay? So cosine theta, I do know my angle is 75, equals adjacent, I do not know, over my hypotenuse, which is 14. I'm trying to get A by itself, so I multiply both sides by 14. So you just do 14 cosine 75 equals and 14 cosine 75. And we are rounding that to the nearest tenth, which is going to be 3.6. This is actually like a real scenario, so we should probably put some units on it. We're talking about feet. So 3.6 feet away from the wall. And that's it. So swoop the angle you know or the angle you're trying to find. Label your sides and then decide what you know or what you're trying to find and which function that goes with. That's it.